Draw a circle and a point on the circumference. Draw the radius, allow the radius to rotate round to an angle of 60 degrees. Drop the perpendicular and complete the triangle. Given the horizontal distance is 2, what is the vertical distance, y? Add the vertical diameter, shift it to the right. The tangent function is given by the opposite, which is the side opposite the angle, divided by the adjacent, which is the side adjacent to the angle. Let's find out the tangent for 60 degrees on our calculator. Make sure your calculator is in degrees. Type in tan 60 and it'll give you a value of 1.732. Let's place the height 1.732 at the angle of 60 degrees. Let us return the angle to 0 degrees. We will put on a trace and then allow the angle to rotate around to 60 degrees. And you can see the tan function being generated for the first 60 degrees of the function. The height of our tan function is given by y divided by x. At 60 degrees, this is 1.732. Mathematically, we can write y divided by x is equal to tan theta. We can rearrange this such that y is equal to x tan theta. We can put our values in for 2 for the length x and 60 for the angle theta, such that 2 tan 60 will give you the value 1.732. Let's look at some more examples. In the first example here, we have the opposite, which is y, and the adjacent, which is 3. So the opposite divided by the adjacent is equal to the tan of 27 degrees. So we can rewrite this as y is equal to 3 tan 27 degrees. So if you go to your calculator and type in 3 tan 27, you're going to get the value of y. But remember to make sure your calculator is in degrees. Now in this example here, we're going to have the opposite, which is the y, and the adjacent, which is the 9. So we're going to have y divided by 9 is equal to the tan of 34 degrees. So if we rewrite this, we get y is equal to 9 tan 34 degrees. So if you put in your calculator 9 tan 34 degrees, you'll get this height y. Now in the third example here, we're going to have the opposite. Now the opposite this time is the value of 7, and the adjacent is the value of y. So there's a couple of ways we can do this. We can write the opposite 7 divided by the adjacent y is equal to the tan of 19 degrees. Now this can be rewritten as y is equal to 7 divided by the tan of 19 degrees. So if you put in your calculator 7 divided by tan 19, then you'll get this length y. Now the other way of doing this is to note that if we were to find this other angle here, which is going to be 180 minus the 90 minus the 19, which gives us a value of 71 degrees, then we can say that the opposite of this is the value of y, and the adjacent is a value of 7. So we can say that y divided by 7 is equal to the tan of 71 degrees. So therefore we can say that y is equal to 7 tan 71 degrees. So if you type in 7 tan 71 degrees, it'll give you the same value as 7 divided by tan 19 degrees, and this will be the length y. Now in the final one here, we have the opposite, which is the y, and the adjacent, which is the 6. So we're going to have the opposite y divided by the adjacent 6, which is the tan of our angle 17 degrees. So we can rewrite this as y is equal to 6 tan 17 degrees. So if you type in 6 tan 17 degrees into your calculator, you'll get the value of y. So let's look at these in the calculator. So the first one is 3 tan 27, which gives us a value of 1.528. The next one is 9 tan 34, which gives us a value of 6.07. The next one is 7 divided by tan of 19, which gives us a value of 20.32. Now that should be the same as 7 tan 71, and again you can see you get 20.32. The next one is a value of 6 tan 17, which is equal to 1.834. So that's all 4 of our examples.